Hello Algebra! I hope you guys are doing great, and on the menu for today we have 5.3, which is going to be the section on multiplication of polynomials, right? So we want to see the way to multiply, so we know what the polynomials are. That's 5.1. We know how to add them and subtract them, and now we are going to learn how to multiply in sections 5.3 and also 5.4, the special products. That's later. So technically we have two things to worry about. We have distribution problems, and we have multiplication also known as foiling. I don't like that word, but it is what it is. Alright, so distribution is going to have some kind of a monomial in front, let's say 3x, and then you have like, let's say x plus 2, where this one distributes to all. Multiplication is going to have multiple terms in each polynomial. So you are going to have, let's say, x minus y times 3x plus 6, in which case you have to multiply each one by each one. So these are the two types. And let's take a look at distribution problems first, and then we're going to take a look at multiplication problems. So it's structured, right? You have one or you have the other one. So let's say you have this problem of 3x times x plus 2. So 3x as a unit times x, that's going to give you 3x squared, and then 3 times 2 is 6. That gives us 6x. So that's what we have for our this distribution. So all you need to do is to take a look at, right, what multiplies. So numbers with numbers and variables with variables. Okay, let's take a look at another example. Say you want to go and say you have x to the fourth times 3x minus 2y. Let's say that's a problem. So how do you deal with this situation? Well, it's the same. It's always the same, right? You multiply this one, you multiply that one, and just be careful with exponents. You have 4 x's on a pile, plus one more x is 5 x's. So that's going to be 3x to the 5 minus 2x to the fourth y. X and y are not the same variable, so we can't multiply them together. If you remember the rule, it said x to the m times x to the n is x to the m plus n. That was in our 5.1 section. We learned that rule of exponents. So here is your x to the fourth times x to the 1 is x to the 4 plus 1, which is x to the 5. So that's how we obtain that one. Now again, x and y are not the same, so over here we just get to list them together. Alright, so 2x cubed, and then we're going to have 4x to the 6 minus 2xy. So this is a little bit spicier situation, but you can still deal with this because this is all one unit that distributes into both, right? So 2 times 4 is 8. And then we have x, 3 plus 6 is 9. We use always the rule which tells us that we add exponents when we are multiplying two polynomials with the same base. And then we have minus 2 times 2 is 4. Then x3 plus 1 is 4, and we just have this y hanging around. And I will pick up something from your homework. Now, obviously, your homework is going to be very rich in negative signs. I haven't done any of those, so let's go. Negative 8 times 4t squared plus t plus 1. Oh, we can have more than just 2 in parentheses. Sure. You can have 60 if you want. It doesn't matter. What matters is that this one distributes to every single one. That's what the word distribution means. Everyone gets it. So we have negative 32t squared minus 8t minus 8. So 8 times 4, that's 32. And then there are no t's with 8, so we keep the same t's as we had before. Yeah, we can do another one. Negative ab times a cubed minus 3b squared. 3b cubed, sorry, 3b cubed. So again, this is all one unit and multiplies into both. So what do I have? Well, a times a cubed, that's 1 plus 3 is 4. So negative a to the 4, and I just have 1b. Because if I just look at this, right, that's the first part that I'm dealing with, there's only 1b, right? So it's just b to the first power. Now, next one is negative times negative is positive. So we have a negative over here and a negative over here. Negative times negative is positive. I should write that, I'll write that on the side just in case. So negative times negative equals positive, right? So that's why we have this plus here. So that's a plus. And now I have I have 3, right? 3. And then I have 1a and 4 b's. And I have 4 b's because 1 plus 3 is 4. So that's that deal. So that's the first part of our multiplication. We always take this entire term and distribute to each member of the parenthesis. So sometimes in parentheses you have 2, sometimes you have 3, sometimes you have 4, and so on. So whatever number of terms you have in the parenthesis, the number or the term in front has to be distributed to every single one inside the parenthesis. So that's our first part of the lecture, 5.3. The second part is foiling or multiplication. Now that is when you have, let's go with x plus a, y minus 3. So now this x gets distributed to both, and then later plus a gets distributed to both. That method is known as FOIL, which stands for first, outer, inner, last. First, outer, inner, last? Yeah, but technically what you are doing is you are distributing the x, which is the red, and then you are distributing positive a, which is the blue. So it's technically 2 distribution problems pushed into one. All right, so let's see. We are following the red first. We have xy, because x times y is just xy. And then we have negative 3x. Because x times negative 3 is negative 3x. And then for blue, I have ay, so plus ay, because that's a times y, and then minus 3a, because a times negative 3 is negative 3a. And we can't really combine any terms because none of these are like terms. So I'm just going to have xy minus 3x plus ay minus 3a, and that's the end. Right? In this case, we couldn't combine anything. So we were more interested in learning, distributing each one from the first parenthesis, distributing each term from the first parenthesis into each term of the second parenthesis. And then we have the red part, then we have the blue part. Let's take a look at example where we could combine x plus 6 times x minus 2. We are going to have the same situation. You have x distribute to both, and then blue, positive 6 distribute to both. Red terms, x times x is x squared, because 1 plus 1 is 2 for exponents. And then negative 2 times x is minus 2x. So we have x squared minus 2x, and that's the red distribution. Then we move to the blue distribution, which is plus 6x, and then 6 times negative 2 is negative 12. So we did red distribution with x and blue distribution with positive 6, obtaining this expression below. Now look at the middle. Those are like terms, and we have to put them together. So put x squared plus 4x minus 12. And that one is going to be the answer, right? Because we finished the multiplication and we added like terms and we're done. So let's take a look at some of these examples that the book is asking you to work on. Problem 44 says x minus 4. I mean, they're all the same, just different numbers. X minus 4 times x minus 7. So we have red, and now we have negative 4 distributing into both. So what do I have for reds? X times x is x squared, and then negative 7x. And then I have minus 4x, and then I have plus 28. So all together is x squared minus 11x plus 28. These two together combine into the middle term because they are like terms, and the rest stays as is. So that's our problem here. Let's take a look at another problem. So what should I do? Let's take a look at x squared plus 4 times x minus 3. Let's say you want to solve that one. The way you would solve this is you would take your x squared term, distribute into both, and then you would take your positive 4 and distribute into both. So what I have is the again red and blue. I'm just going to give you a few seconds, right, to try this one on your own, and then I'm going to do it. So no pressure. You have 18 seconds. Actually, you can pause the video. I don't need to wait, right, like in class. I can just pause the video and you can pause the video and then all right. So red one. what do I have for red? Well, I have x squared times x. Exponents are 2 and 1, which means that I am going to add 2 plus 1 to get exponent of 3. So when I multiply x squared from the red, when I multiply x squared to an x, I am going to get x cubed. So we start with x cubed. Then I am going to multiply x squared into negative 3 and get me negative 3 and get negative 3x squared. Then I have the blue, which is plus 4x, and finally negative 12. So there is nothing for us to actually add over here, because there are no like terms, right? Everything has different exponents, and because they have different exponents, we just have to just leave them as they are, right, on the pile like this. All right, let's work on one that has more than 2 terms inside. So x minus 2 and x squared plus 4x minus, let's say, 3. So when you have this situation, you will be multiplying everything in terms of the first term will go into all of the other ones, right there, and there. And then the blue one, which is negative 2, will go into each one. So now we are going to end up with 6 terms. So what are my red ones? Well, x times x squared is x cubed, because 1 plus 2 is 3. Then I have plus 4x squared. Exponent on x is 1, exponent on x is 1, 1 plus 1 is 2. And finally, minus 3x. So that's our 3 red ones. Now we have 3 blue ones. Those blue ones are on the bottom, and we need to have those also presented, right? So I have negative 2 times x squared is negative 2x squared, and then negative 8x, and then negative 2 times negative 3 is positive 6. So now this expression, right, has a lot of like terms. I have a like term here for the x squared, right? X squared has a like term, and then this linear x, single x, also has a like term. So I can combine those. Now remember to put your answer in a descending order of powers. So x cubed is first, then 4x squared minus 2x squared gives me positive 2x squared, and then minus 11x, and then plus 6. Right, negative 3 minus 8 is negative 11, right? Because it was negative, and then you made it worse. You made it more negative, right? So we went into negative 11 right there. And let's have one more problem. Now this one is going to be a little bit different. This one will have 3 in front. So 2x squared minus 3x minus 5 times, let's go with 4x squared minus 3, whatever. Literally whatever. You can practice these problems just by making them up, right? What's important is to understand that we're going to take the first one into both of these. Then we're going to take the second one into both of these. And then I have a third one. Should we do the wood paneling? Let's go. This one will also go into both of these. So now, since we have 3 in front, right, each one needs to distribute. Okay, so what are the red ones? What are the red ones? 2x squared times 4x squared. Well, 2 times 4 is 8. X to the 4th, because 2 plus 2 is 4. Then I have minus 6x squared, because I am multiplying 2x squared into negative 3. Right, so 2 times negative 3 is negative 6, and then you just have x squared. Then we're moving to blue ones. Negative 3 times 4 is negative 12. And then exponents are 1 plus 2 are 3, so x cubed. And then I have negative 3 times negative 3 is positive 9. Right? We did say it earlier, negative times negative is positive. So negative 3 times negative 3 is positive 9x. And those are the blue ones, right? The blue ones. And now the wood paneling. Negative 20x squared plus 15. Do I have like terms? Yeah, I do have these ones, right? X squared and x squared. Everything else is not like. So the highest exponent is to the 4th, so 8x to the 4th minus 12x cubed minus 26x squared plus 9x plus 15. Okay. Now, one more thing that I want to talk about when you get problems like this. It's easier to work these problems out, and it's less confusing when you have the parenthesis with less terms first. Now, I hope that you remember that multiplication is commutative. And commutative means that A times B is the same as B times A. So this problem can be written as 4x, what was that? 4x squared minus 3. 4x, come on eraser, 4x squared minus 3. I can flip these. Times 2x squared minus 3x, was that minus 3? No, minus 5. Minus 5. And if I FOIL now, which is what we are used from before when I only have 2 in front, right, I will still get the same 6, but I'm not involving 3 colors, right? I'm just going 4x squared throughout and then negative 3 throughout. So it gets, I think it's easier. So 8x to the 4th plus minus 12x cubed minus 20x squared minus 6x squared plus 9x and plus 15. And if you take a look at these guys over here, these guys are like terms. So we have 8x to the 4th minus 12x cubed minus 26x squared plus 9x plus 15, which is the same answer as we had before, except this way I think is a little bit less mess. So you are allowed to swap the parentheses as long as you have multiplication in between or addition, right? So you can swap them around, and then you can just use the distribution method that has less of these. I use the colors, right, to show each one of the distributions. So if you have the smaller polynomial in front, right, the first, then you have less distributions. I mean, in the end, you'll have the same amount of terms, but you'll have less distributions, and it's easier to just run first one through all and the second one through all. You know, so try to have as little as possible. So that's it for 5.3. The homework will open soon. I hope you solved 5.1 and 5.2. And keep your eyes on announcements in Canvas, because that's the way I communicate with the class now. So you need to be, reading those. And then if you have anything that you would like to discuss with your classmates or me, right, which is a public discussion, just post in discussion posts underneath the lecture, underneath the announcement, and then we can all chip in. So keep watching the announcements, and I will be posting about exams and quizzes and everything else there, because that's the only way to communicate right now. See you later. Bye.